Hi, everyone. This is Tijay from Virginia Tech. First of all, it was a really pleasant journey to do the mentors as a mentors program as a mentor and to work with two really great ambassadors. So one of the other my role was to work on this RoVista. So RoVista is a work platform to measure RPKI, ROV, root origin validation status at scale. So let me tell you how it works, and let me also show you the demo platform. So for those of you who are not familiar with RPKI basically provides a cryptographically verifiable database for routers to verify all the incoming BGP announcements. So there are two roles in RPKI. The first one is the research owner, for example, Virginia Tech, who has its own AS number and prefix, has to publish its assertion that, hey, I'm the owner of this IP prefix, and also I'm entitled to announce this IP prefix. So they can do so by creating an object called ROA, and they have to upload it to the registry. And the other one is about routers. So router also needs to download these ROAs from all these registries and use them to verify BGP announcements against them. So there are two perspectives here, resource owners and also the verifier, which is the router. So there can be two questions here. The first one is how network owners, resource owners, use RPKI to protect their resources. And the other perspective is verifier's perspective, which is how network owners, operators, routers use RPKI to protect the other resources. So there are two different perspectives. Okay, yeah. So there can be two research questions. The first one is, as I mentioned, how network operators use RPKI to claim their IP addresses. And the other one is how network operators use RPKI to filter out invalid BGP announcements. Answering the first question was really straightforward because all we can do is just go to the 5 registries and download these ROA objects and to see how many IP prefixes are in the ROA object so that we can answer these questions relatively easily. Can you go to the next one? But the other one is really hard because simply, if we want to know if one ISP uses RPKI to filter invalid BGP announcements, then it is really hard to imagine how we can validate it because we simply don't have any access to their routers. So in this work, we built a methodology and a platform called RoVista, which is an active measurement platform that tracks the ROV status of network operators using two techniques. First one is in the wild prefixes. The concept is really simple. When you take a look at the BGP announcements and whether they focus on those who can be validated using RPKI, then you will see a small percentage, like 1% or 2% of verifiable BGP announcements are actually invalid due to mismanagement or due to some attacks. So we are using these prefixes to tell whether some network are using our ROV or not. The other technique is IPI side channel techniques. In a very high level, it allows us to measure the connectivity between two remote end hosts. So combining these two techniques, we measure how many network operators in the internet use ROV. So we are currently covering about 30,000 ASs. Most importantly, we're running a platform on this URL. So we are providing a data set as well, and also API so that you can batch all the ROV status of the network of the AS you're interested in real time. And also, we are also publishing all the source code publicly available. This work was published at IMC this year. So if you're interested in a detailed technique, please refer to our paper. So let me show you how the website works real quick. Yep, this is a webpage. The first one is just the overview, how it works, and the link to our paper. And the second one is the overview of our risk scores for all the ASs that we have measured so far, and which are ranked by the AS rank. right? So if you are interested in, it also provides a search function. So let's say if you're interested in orange, which is a big AS in France, then you can click this AS number. They will show you the ROV ratio, which is how many, the ROV scores are basically measures that tell you how this AS performs ROV. 0 means it never filters out the invalid prefixes, and 1 is it perfectly filter out those then. As you can tell, it enabled ROV on June last year. And if you're interested in what kinds of invalid prefixes they ever forwarded, you can just click this point. They will show you all the target IP prefixes information so that you can actually test by yourself by using your recent data whether they are actually filtering out invalid prefixes. And also we are providing a API so that you can go here and then you can test all the APIs that we provide in here. And if you're interested, you can reach out as PhD students, Wei Dong, who led this work, and also myself. Right. Thank you.